From Central Point, Oregon, headquarters of Microvellum Software, this is Microvellum Live. Thank you so much for being here today. If this is the first time that you've joined us here on Microvellum Live, we host these free educational episodes weekly. And if you want to catch up on anything you might have missed on these live episodes, you can find them all on our website at microvellum.com/live. And if you have not already signed up to follow us there on YouTube, make sure you do that as well. That way you get notified of when we go live there on our YouTube live stream. Well, you have a couple different ways you can participate in today's episode. You can chat with us there using the chat window that many of you have already found. And you can also chat with us there on the YouTube live stream. We have people monitoring both chat tools there. And if you have a specific question, be sure that you use the Q&A UI there in Zoom, and we'll make sure that your question is answered. And who knows, we may be even able to answer it live for you today. And as usual, we are recording today's episode, so you'll be able to catch up on anything that you missed a little later this week at microvellum.com/live. So today we've lined up a few different presenters for our Q&A session here. We have some developers, some technicians, even an account rep there in California who's going to help us out to show you some of the hot topics that we've encountered over the last month or so. And we're even going to be showcasing some new tools, some new functionality coming out with our solid modeling tools. So if you're using those tools, you're going to want to pay close attention to the part presented by Dominic. And if you have ever wondered how to perfect grain match an entire room, well, Shane is here and he's going to help us understand the workflow to make that happen. And Daniel has joined us again, and he's going to be helping us answer a recent question that was asked on our user forums related to user-defined project properties. And do you ever have the need to add lettering to a cabinet? Maybe you're working on a restaurant fixture. Maybe you need to put that, also common trash wording there on your one of those trash cabinets. Maybe you're making a sign or something else. Well, Travis has joined us today, and he's going to show you his workflow that he uses for that. So we have a full lineup today. We may run a little over the scheduled hour. Hope that's okay. And if you need to jump off, you can always catch the recording, but might be going a little over the scheduled hour. So without further delay, let's jump right into our first topic. And remember, feel free to ask questions at any time, whether it's related to the topics that we're working on right now, or you have a question on a different subject. We are here to make sure that those questions are answered. So we're going to hear from Shane, and he's going to help us learn how to grain match an entire room.
Yes. Hi, Clay.
Hey, how's it going?
Good. So yeah, we can definitely do that. So yeah, we have had the ability to perfect grain for a while, and we've also had the ability to grain match a room together for quite a while, but we've had a few questions come up as far as how it works, some of the different things you can do with it, what it means. So we're going to kind of show you a few examples today of it in action and some different things you can do with it. So as you can see here, I have a wall drawn, some cabinets on it, and this is drawn with our latest library. And with our latest library, we have the ability to put the identifier, these numbers here. So you can see in this case here, I have a #2 and a #3 on these. So what that is actually doing behind the scenes is, if I switch over here to the perfect grain info column, which is typically what you'd have a 1 in before, telling it just perfect grain, and it would grain that room or that item together rather. So it would grain everything with 101 together as a unit and 102 as a unit. So now, what it does differently is when it has that pound sign, that's the key there, that little pound sign, it will then all of those numbers together, and it will make that a unit. So in this case here, you can see I got #2 on all of my base cabinets and a #3 on all my uppers. And so what the optimizer does is it sees all of those units, it'll get all of the identifiers and group them together and then nest it. So, and this is what that looks like all nested. I did this before for sake of time, but you can see it did all of my bases there, and it did all of my uppers on this sheet all together. So there's a lot you can do with that. And got a quick note on a warning on that. This wall is only 90 inches long, and it did it on purpose. If it was to say 120, if I didn't have a sheet that was 120, and it's going to try and group it together as the size it was. It doesn't know to split it up because it's just grouping it together. So as you're designing it, it is important to watch your sheet sizes and make sure it doesn't go over that. But if it does, it will warn you when it's nesting it and saying, hey, I couldn't group these together, and because I didn't have this sheet size big enough. And so you have to go back to the drawing board, maybe shrink it up a little bit or add a different sheet size to get it to work. So that's a note on that. So let me show you some different examples. This is the same exact wall. It's a room, or rather just copied it down, and now they're just ones. And so what this is our normal way. So we're just going to group this cabinet together, and then this cabinet. This is our normal algorithm there. Some other things you can do with it. You can split these things. So I've done a couple scenarios here. So you can notice here, the identifier for the doors are different from the drawers. And so it's going to group all of these doors together as a unit, and then we'll group all the drawers together as a different unit. Or you might do it this way. You might do the left side of the cabinet and the right side of the cabinet. So by switching out that identifier, you can do a lot with this thing. And so it might save a lot of sheet size, or you might get better yield if you did it this way, if that's what your preference is. And so like I say, by changing these identifiers, you can do a lot with it. It also works. I have a few cabinets drawn, which I've did the same thing. So in this cabinet here, you notice there's a big space here. So I got doors on top, doors on the bottom, and they're both the same identifier. So it's going to try and group them together, but it knows there's this big space here and they're in the same plane, and so what it's going to do when it nests it is it will actually get rid of this space, and these doors will end up on top of each other. So there won't be no space there. And so for the sake of keeping your yield together. It is very easy to implement this into an original library, into your older one. The reason I use this one, because it's easy to see the identifier. But like I say, all it is really coming into your part properties. Let me go switch back to part properties here. Just go up to this one up here. Not that one. So I just went into my door, and the perfect grain info there is #2. And so to making sure all your perfect grain infos for whatever you want to group together, just make sure they're the same information. So if I went to this one here, the upper it would say #3. I don't know, James, you had a question, which one is the earliest we had it? I'm not 100% sure. I'm thinking, I thought 44 had it. Maybe it might have been 45. It was the earliest. I am not 100% sure, but like I say, it's all a matter of just putting it in that perfect grain info, putting it in. And it is very simple with these options here to do. Where did it go? So this is my global variables for this library. It's as simple as turning it on, and then you can tell it to either allow across multiples, or I can tell it to split the double, which is I show both of these examples, split the doors from the drawers, or split the double width cabinets. So, and also show it on the elevations. This is a new library. It is very easy to do, but it's also pretty easy to hook up to an older library too. So hope that helps. That's about all I had, Clay. Any other questions?
No, I think you did a good job there. Again, if you have additional questions, those who are tuned in here after we pass on and get on to some of the other presentations or demonstrations that we've lined up, feel free to ask those. Shane will be sticking around and can answer those questions for you. So thanks a lot, Shane, for showing that off. I think that did a good job there. So now I think we should turn things over to Daniel. And he's going to help us out with a question, or the answer to a question that was posted on our user community from Billy in New York. related to our user-defined project properties. There's quite a few people following that thread there, and looking forward to seeing how you've developed this, Daniel.
Hey, Clay, thank you. So yeah, as Clay mentioned, up on our forums here, someone just asked how to use user-defined project properties, and a few other people chimed in wanting to know how to actually go about using those and what you can do with them. So I thought we would just kind of go over a review and see what we can do with the project properties and how we can use them on inside of the AutoCAD drawing and in our reports as well. So the project properties, they can store specific information related to the project, and it's kind of stuff that doesn't really exist in the specification group. So it may not want to change construction, but you just want to keep notes about a specific project or a property that you want to show on your drawing or a report. And that's where these project properties can become very useful and very powerful. So let's take a look at how we access our project properties. So I have a project started here. You should be able to see my screen. And in order to access our project properties, we'll go to our project setup tab here. And the first set of project properties that we're going to discuss are the properties that are on the project information tab. Now this screen, this is not customizable by the end user, by you guys, but this is just default information that is available that we kind of figured most people would want, and we can add to these as we see fit, but again, they're just static and you can come in and enter in information that you want. So for example, we have job description, number, phone, so you can just go ahead and enter in any sort of information that you want, and this information will be associated to the current project. This information, as I mentioned, we have the ability to process out information or not process out, but put information from the project information tab here into our AutoCAD drawing. You may notice, I'm going to go ahead and save and close this here. In a lot of our default title blocks, we have our title block set up to actually pull in like the job name, and all of this information comes from that project information tab. If you want to know which, and I'll kind of go into this a little bit more, you'll see how this works, but here's just a quick preview of all of the different project names that we have, or the property names, and the title block attributes that need to be associated if you want to make your own custom title block. And we're going to go over that in a little bit. This also shows you the database information as well. So we'll be sure to post this information up on our website. You can also access this right now in the existing Microvellum help file, which you can access by just hitting the F1 key in the OEM, and you'll find that information I just showed you in there. So you can kind of refer back to that if you want to make your own custom title blocks. So that is the project properties that are set up in the project information tab. Now, if you want to create your own project properties, this is where we would go to pull information from our global variables or our project wizards, and we can do that by going to our user-defined project properties tab here. So by default, all of the properties are coming from a template, and so we can create a template level property, and all the template level properties will get pulled in every time a new project is created. We can access our template level ones by right-clicking, and we can say show template project properties. So this is going to open up this screen here, and this is where we would actually go about adding or redefining the existing properties, and then any of these will get pulled into any new project that we create. So we'll go through and actually add a new project property here in a second, but there is one more type of project property that I want to discuss, and that is location-specific properties. So all the properties that we've seen so far, this is information that's going to be available throughout the entire project, but there may have a need where you want properties that are just for a specific location or a specific room inside of your project. And you'll see that after we open up a room, we have the ability to access our room properties. Now these are going to work exactly like the user-defined project properties. We can right-click and add new ones and edit them. We can also set up template room properties. So once you kind of understand how the user-defined project properties work, you can come into the location-defined or location-specific ones and set up location-specific properties that can get pulled in for every single location that you create within your project. So let's go ahead and take a look and create a brand new project property. And the project property that we're going to go create is we're going to pull information from our project wizard. So lots of information we can find in our project wizard, such as if we go to our hardware, so we can find different hardware selection types. So this information controls how the product is going, what hardware the product is going to use, but we don't really have a way to pull that onto a report or put that in our drawing. And so we can use our user-defined project properties to do that. So here we have a defined name, which is our hinge type selection. So what we'll do is we'll create a brand new project level property, and we'll just select that option here. And we'll give this a name. So we will just do hinge selection. And the value we're going to go ahead and leave blank because it's actually going to pull from the existing project wizard. And so the next two options here, the global variable name or the project wizard name, this is where we can select which defined name we want to pull from. So in this case, we were looking at the project wizard. So we'll go ahead and select that. And then in our search here, we'll just type in hinge and we'll do the hinge type selection and hit OK. So now it's going to look for this defined name inside of our project wizard. If we had multiple defined names or multiple project wizard files within our project, we can use the specification group and tell it to pull from a specific specification group. If we don't have a specification group selected here, it's just going to pull from the current one that is currently being used. So you have the option to go to a specific one if you want, or just use the current specification group. We also have the ability to pull in this project variable name here. So if we look at this list, this is a lot of that same information that we saw on the project information tab that we were looking at earlier. So this is just a way that we can pull in, say, the job number and then assign it to different AutoCAD blocks instead of those defaults that I showed you earlier. For now, what we're going to do is we'll set up the title block name and attribute here in a minute once we create that block inside of AutoCAD. But so that's the basics of just creating a new property. All it really needs is a name, a value if you want to populate that, and then what type of information it's going to pull from. So we'll go ahead and hit update, and you can see we have our hinge selection. And in order to pull the information from the specification group, we have this update database menu item here. So what this will do is this will go through all of our project properties and pull any data that is looking to specification groups into our values here. So we can see that that hinge selection now gets populated with Bloom, which is what our project wizard was set to. So you can kind of see the connection there between the project properties and the specification group information. But now we want to go ahead and put this information into our drawing. So we're going to do that through setting up a block. And to be honest, I just was kind of fumbling through this a little bit. I don't set up blocks a whole lot in AutoCAD. If this is something that you're going to be doing quite often, I definitely recommend just going to the Autodesk help site and look at how to create a block. They have a lot of tutorials that you can go through to actually go through step by step, but we'll go ahead and just kind of show you what I went through here to pull that information from our property into our AutoCAD drawing. So the first thing that we're going to do is we need to create our entities that we're going to use in our block. And for this, I'm just going to create a line. So this is our block, and we're actually going to pull or apply a title block attribute to that. So first thing we need to do is make this a block. So we use the block command, and then we're going to select our objects, which is just our line right here. This would probably want to be something a little bit more elaborate, like a title block. You'd have, lots of different text information and objects in this block, but we'll go ahead and just select our line for now, and then we will select, or we want to enter our name, so I'm just going to call this my block, and then we will hit OK. So now if I list this out, we can see that instead of it being just a line, it's now a block reference, and the block is called my block. So now we actually want to assign an attribute to this, and the attributes is how we link the information from the project properties to the block itself. So what we'll do is we'll select it and then right click, and we'll go to our block editor. And up at the top menu here, we have this attribute definition. So this is where we actually set up the attribute, and this information that we enter in is how we link it to the user defined one. So the first one that we want to use is this attribute tag. This is kind of like a defined name inside of our spreadsheet. It's a specific tag that gets used that we will tell the project property to look for. So in this case, we're going to name this hinge type. And the prompt here, we'll just do hinge type again. And the default, we'll do a hinge value. This default value will change once we actually populate this information from our properties to the attribute value. So then we'll go ahead and hit OK, and now it's going to ask me to enter in or select where we want to place that attribute in our block. So we'll just place it at the beginning of that line there. And then we'll go ahead and save this block and close it. Now there's one command that we needed to use to sync up that attribute information to our block in the drawing, and that's the BATTMAN command, the Batman command. So that's the block attribute manager. So what we'll do is we will scroll through our selection of blocks, and here's our block that we created here, and then we'll just go ahead and hit sync, and now we see that we have that prompt hinge value showing up inside of our drawing. So now what we need to do is we need to tell our user-defined project property what title block to look for and what attribute to look for. So what we'll do is we'll go back to our project property, and we will edit this guy. And so the title block, the name of the block that we're going to look for is that my block. And then the attribute name was hinge type. So that is that special defined name that we entered in earlier. So we'll go ahead and do update, and then we will save and close. So now we want to go ahead and update all of our blocks with the values from our user-defined list. So in order to do that, we'll just do update title block, and this not only will update the information in our title block, but it will find any block that is inside of our model tab and try to update values from the user-defined project properties. So we'll go ahead and do that. And it's just going to let us know that it might take a few minutes depending on the number of blocks that we have and number of properties. So it went through and updated that. You can kind of see in our main title block here that project number that we populated gets populated in our main title block on our paper space. But if we jump back to our model tab, you can see that that value now gets populated from our user-defined project properties. So now anytime that I go into my wizard and I change my hardware, and then next time I go and update the title block, it will go ahead and keep that information in sync with our wizard. So very powerful to be able to pull in information and preview it inside of our drawing. The last aspect of using the project properties is actually being able to report off of these. Now we have done a few MB Live events that have gone through and talked about the reports, so you need to understand a little bit about how the reports work, but I just kind of want to talk about some of the database tables that you can use to report off of this. I'm not going to go into too much detail about the types of reports and how to create that, but I just want to show you the database tables and where you can find the information stored in the Microvellum database. So here I made a report. It doesn't have anything in there, but if we look at the data sources that are used for this report, the important ones that you want to pull from when dealing with the properties is the projects tab, or the projects database table, and project properties. With those two tables, you can find all of the properties for the locations, for the project information, and the user-defined ones. So what we'll do is we'll jump into the designer here just so we could take a look at that table. And we talked about that project information screen, that first one that had those default properties there. All of those are going to be found in the projects database table. So if we view this data, you'll actually see here is a list of all of the projects that are inside of my database, and then all of those properties. So here's that job number. If we populate a job, phone, fax, email, etc., all of these would be populated. So you'd be referencing these database tables and columns to report off of that information. And then the project properties database table, if we view this data, this is going to have all of the user-defined and the location properties in here as well. So we can see that last one. Here's that property name hinge selection. It's populated with that bloom. It also gives us the, which title block it's populated to. So we could report off of this information in any report that we want as well. So anyway, that's a real quick overview of the project properties. Hope that gets everyone pointing in the right direction. And I'll send it back to you, Clay.
All right, great. Yeah, thanks for that. That was pretty in depth, and I hope that those who are following that community post there, that you've learned a little bit more and we provided you a little bit more insight onto that. So yeah, thanks a lot for helping out with that, Daniel. All right, well now it is time to talk some more about our solid modeling tools. And we are about to unveil some new functionality for unwrapping the skins of curved and even tapered products. Many of you using these tools have probably wondered how we handle that. And so here to help us with that, an explanation of that is Dominic. So thanks again for being here, Dominic.
Hey, Clay. Happy I could join you guys.
Yeah, I am looking forward to seeing what you've got cooked up here.
All right. Well, let me start by sharing my screen. It looks like Daniel's going to have to. All right, cool. Well, for the most part, when Solid Model Analyzer started development, it was made for flat panel type of geometry. So that's pretty much anything that you'd be able to machine using a saw or a nest, and then maybe a point-to-point machine, and then put together a cabinet. So that's worked well for our common products because all those parts are planar, meaning that they will all fit on a single mathematical plane. But as we introduced more tools to our solid modeling set, the need started to present itself that we needed to support things that were not planar. So I'll give you an example here. This part right here is basically flat. That could contain any type of machining that anybody would want, and it could be turned into a cabinet top, side, door, whatever the case is. But coming to a part like this, where it's got a compound curve, there's a lot more math going on there, and for the most part, it's not something that you would usually be able to easily machine on a nest or cut out from a saw and then go from there. People now have the ability to create these things with our extruded products in the solid modeling tools, or maybe even in the unique products. So we decided to support them. So to get back to your question, there are planar parts, a part that will fit in a single mathematical plane, and then there are non-planar parts. So as the need is grown, it was deemed as a priority to make sure that we're able to support these non-planar parts. You can imagine working with a product maybe like this. There are many non-planar parts here. Maybe I'll put this in conceptual view mode, that way you can see what's going on. So we've got these strips that essentially go around this curve. If you look at this curve, it's not actually just a cylinder, it is a section of a cone, because it's what in our industry we call tapered or maybe compound skin. So there was the need to be able to flatten things like those strips, and also these items here that we're looking at. So this is a couple of different sections of a skin in the front that represent part of a cone. So we've been hard at work, starting with very simple items that would maybe represent half a cylinder or something like that, moving on to different sections of cones of all different types, and then getting more complex from there. Started to add machining to these to make sure that we were able to support that. So what you see, what I've done is try to really put it in a nutshell here. You've got 5 different sections of what could be a skin for an extruded product, whatever that may be. And it won't do you any good to have that information. What you need is to be able to flatten it as an end user and then machine it perhaps on a nest machine or by some other means. So as you can imagine, a shape like this may be simple to model here in AutoCAD. If you see, I just modeled the cone and then I just ran a cylinder through it and was able to subtract that. But then when you start to really look at it in 3D, that shape is no longer cylindrical or circular. It's actually got an oval and some complex ellipses. And once I start applying the flattening algorithms that we developed, you can see that now you would be able to machine this as a flat panel and then pick it up and wrap it around the product that you would be working with. So we've got some cones here that start a little tighter at the top. We've got the machining that went ahead and was translated there, cylinder types, and then some inverted cones depending on the product that you're working with. Everything clear so far, Clay?
Yep, makes perfect sense.
Okay, I didn't mean to wake you up, man. Sorry.
No, I was just sleeping over here. No,
All
there
right.
was the question there that might be on some of the minds, the people watching here. What this is developed for is not exclusively for, like, let's say if you're using the extruded tools. This is basically at the heart of the analyzer that these changes are made.
Yeah, so sorry if I didn't clarify that. What we've done essentially is given our users the ability to easily create this complex non-planar geometry with the extruded products and solid modeling tools, but then we needed to be able to give them the ability to machine it. And so that was this next step. But all that is baked into the core of the solid model analyzer and its accompanying spatial engine. So if somebody was sent solids that aren't necessarily produced by the solid modeling tools in Microvellum, they should still be able to be analyzed and flattened so long as they're actual 3D solids.
Right.
So what I'd like to do to just kind of show you how this would work out in a real world scenario, I took some time to model this guy up. As I showed you, there are 4 sections to the skin here. There's a flat, let's see if I can highlight these so you can see the difference. Yeah, so you've got this flat section here that's not highlighted. You've got a quadrant of a cone there, another quadrant, and then a flat one. And then inside where the hostess would stand, she's got her countertop and everything. So we've got a couple of different skins here that are actually part of a cylinder and then go into a straight skin. So it's not a complete cylinder. And the same here. And what you'll notice is we've got these cutouts here for an outlet, like a 4x4 plug or a 2x2 plug, so that the waitress can browse on her, or the hostess can browse on her phone while you're waiting to be seated. It's very important. So what I did was, for the sake of time, I went ahead and ran this through the analyzer, and I'm going to show you the nest that came out from this. So I made my sheet sizes really large for these strips. There's probably several different ways you can do this. If you just wanted linear footage, you could gather that from the part dimensions. But then here with our skins, so you can see I left this piece, let's pull this guy out, as one single entity, because maybe it's just something that I buy by the foot and a roll and not by the sheet. And the cutouts that I had there are translated over so that they will come out in the nest. Those 2 front quadrants that we were talking about are right here. They've been laid out flat for us. And then those accompanying corners. Then, of course, you've got your countertops and your studs. These were all planar parts, so this didn't actually go through the flattening part of the solid model analyzer flattening algorithm. And these are all nested out for us. So in the end, what this does for you is takes out a lot of complex geometry and trig that you won't have to worry about anymore. You just make sure that your 3D solid looks the way you want it, and our algorithms will take care of flattening that for you so that when you pick it back up and are ready to wrap it around your product, everything is going to fit accordingly. So right now, this is being developed to the point where I'm able to demonstrate this for you here. It's going to be available a couple of weeks after TechCon as part of a beta to our user group. I think we'll have some workstations there at TechCon for people to start working with this and playing with it. And then later on in the summer, it'll be available to the general public. Am I missing anything, Clay? Any questions?
Nope, I think we did it. I think we got all the questions answered there that I saw coming in. And yes, if you are coming to TechCon, you'll be able to get your hands on it in terms of using it at a workstation that we've got set up there. And then following the event, you'll have it if you're in the user group there to be able to try it out for yourself. Yes, one of the biggest points to take away from this is that like there's a statement there from Rod. Rod, you are using the solid model analyzer. And so if you can model up with what Dominic is showing you there without the solid modeling tools, which should take you quite a bit of time actually probably, then we will be able to unfold all those parts and fuse them together as needed. The solid modeling tools, like the extruded tools, would obviously allow you to create that type of product in just a few minutes. Yeah, so this is available to those who just got the new, so if you're in the premium tier, we did recently open up access to the solid modeling analyzer for you. So you will have the ability here to be able to model up some things and to add machining as Dominic here has demonstrated, and we'll unwrap that and create the code and optimized parts for you. So that is an exciting feature to have, one that a lot of people have been asking about recently, and so I'm glad that we were able to show it off. We're going to learn a little bit more here at the tail end of today's episode on how to do some lettering and how to create some signage using Microvellum. And here to show us his workflow is Travis. Thanks for being here, Travis.
Yeah, no problem. Cool. Yeah, so what I did is I just created, if you can see my screen, just a simple little sign used. I just put TechCon 2018 on there with the Microvellum logo. So what this sign would do is basically we would be routing in everything here 1/4 of an inch, leaving the Microvellum logo sticking out 1/4 of an inch. And then this material around here would be staying at the surface while engraving in the words TechCon 2018. So I'll just show you real quick. I'll try and make this quick so that everybody can get on with their day. But what we've started out basically is some text that we've just entered in AutoCAD, a circle, and then this is a file that you, Clay, had given me. It's a DXF file. So I've just taken those components and I'll show you how to make a sign out of that. So started off here with drawing that circle in there, just copying that little Microvellum triangle over here. The next thing we did is create some text. So by creating text, all we're doing is typing T and choosing whatever font that you want to use. Have Arial here. We'll go at 5 inches. I'll center it here, and I'll just write TechCon and then 2018. The 2018, I'm just going to shrink down to 4 inches, and we'll say okay. There really isn't anything that you can do with text at this point. You have to modify this text. So the way that you can modify it, we need to get it down to a polyline so that we can assign a route, a border route to it. So what we need to do, there's a command called WMF, WMF out. So you'll click that. I like to save it on my desktop just so it's easy to find. We'll just call it something, call it anything you want. This one I'll just say sign 4. We'll save that. Now you type in WMF in. You can see it usually populates. Find that one there, sign 4, open that. And as it brings it in, it's going to say specify an insertion point. You'll just click wherever you want that. It's going to ask what scale to bring it in. I found that entering it in the X scale at 2, enter. At the Y scale, 2, enter. And then rotation is just 0. So what we've now done is we've brought in this, basically the outline of that word that we want to modify. What you have to do next with this here is explode it twice. So X, circle around it, and do it one more time. So now that we've exploded this twice, you can see we have all kinds of little tiny lines now out of this part. At this point, you'll see that there's some little funny lines that got left in there. You'll just erase all of those out. And so once you've kind of gone through and cleaned your lettering up by removing those lines, this is what you've got here. So I've removed all those lines. We still have all the little bitty lines in there. After this, you just type in bpoly. You want to connect all those lines. So you'll pick the internal points of each of these. And once you've done that, you've now created a continuous polyline out of that outside line. Once that's done, all of these have been created into a bpoly. I like to just select the outside, just a one click on each of these, and then move those so that you don't get the lines underneath. So that's what this looks like here. We have a single bpoly line. And the next thing we're going to want to do is offset this line. I found it's a lot easier to do a center line route. So whatever bit that you're going to use, in this case, let's say we're going to use a 1/4 inch diameter bit. I would offset this line 0.125. So just O and then 0.125. You'll offset on each side of that line. And then you do that throughout all your letters. Once you've done that, you've got, this is what it would look like. You'll want to assign some machining to that. So you're going to open up your tab, your nest editing and 2D machining tools. You're going to go down to your routing tools and then click on whatever tool that you want to use. This is just the default ones that come stock with the program. So I'm going to select this 0.25. It's going to automatically come in at 0.25 depth. You can type in whatever other depth that you want here. I'm going to say I want that tool to be center, and then pick the existing entity. We collect that line and right click. And so now we have a tool path along that polyline that we've created. If you don't want that to just drop straight in, there's other tools that you can do under route editing tool. You might want to add a lead in so that you can ramp it in. If you're doing lettering, I would suggest turning off the arc lead and just have it ramp. And then you click add lead into the polyline, bring it into somewhere where you're going to want it to ramp from. And so again, you can go through and just add machining to all those interior lines there. Once you've done that, this is basically what it's going to look like here. I've just, at this point, copied over the original simple outline with the Microvellum logo. And I've inserted, just copied over those letters to here. Let me just take this out so that everybody can kind of see what I was doing here. Let's just bring this one over. I'll copy it over here, and then we'll just copy this down to wherever you think is going to look good. I'm just going to fling it in there. Say this top area here, we want to use a 1/2 inch diameter cutter, and we want to go in 1/4 inch deep. We want to save this and make everything surrounding that be recessed. So we'll offset 0.25 on this one here. This kind of has a funny little curve that comes out, so I'll just use the fillet command and just clean that up. So now we've got that copied around. I also would make a bpoly of the inside here to create a region. Click that. So now we've got a polyline outside and around that that logo. From here, I would just offset 0.4375 because you don't want to do exactly the diameter of your bit. You want to kind of overlap just a little bit. So go 0.4375 gives you just a little overlap. And from here, you can just kind of come in and start making your paths along here. Once it starts overlapping here, then you would stop around the perimeter. I would trim this outside line and get rid of anything that came inside of that path. And then from there, you can do another bpoly, offset all those lines. Eventually, you'll get this here, where you have all these polylines that are going to be router paths around. Again, do the same thing that you would before. You go to your routing tools here. You're going to grab that 1/2 inch bit, whatever depth that you want to cut that in, hit your center line, assign those there. And that's basically what you get at this point. We'll want to draw a panel. That's pretty easy to do. You go back over to, oh, excuse me, it's right here under your nest tools. You'll have to put a work order there, whatever material you want to cut it out on, 3/4 MDF, put your panel size there, draw, throw your panel in the drawing here. So now we've got a panel. copy those parts onto this panel. And then from here, you're just making a new G-code file from drawing, selecting the border, and then calling it whatever name. And now you've got a program that you can run. So this, could be useful if, like you said in the beginning, if you had a little cabinet that had a need to say trash, or you want to make a little plaque for a doctor. I don't know. Anyways, doing lettering, sometimes it's kind of hard, because especially when you're working with a text that you can't really do anything with, those commands WMF in and WMF out, that will really help you out. You can do it for a lot of other fonts there as well. You can get some fancier fonts there, do the same thing, create yourself some polylines out of it, just by doing that. So kind of something that could be kind of fun, hopefully a little bit useful as well.
All right, thanks, Travis. Looks like there's a question here from Andrew. Did you demonstrate, maybe I looked away, demonstrate how to add the ramping into the corners?
Yeah, so what you would have to do, say you wanted to ramp this in here, you go back into your tools, you'll go to your routing tools, and then a route editing tool, excuse me. You could either do an arc lead in or ramp lead in. So here's where you would select add a lead into the polyline. You'd select that polyline, show where you want that ramp to start from, and then pick that, and it's going to ramp in at that point there and then continue along that polyline path.
Great. Thanks for that question there, Andrew. All right. Yeah, thanks again, Travis. This seems like a pretty simple process, something that is probably not a lot of people watching have seen. And to answer there, Rod's question, yeah, this is very interesting, and we will separate this out into its own video, post it there in our help documentation for others to watch. So yeah, and we thanks again, and we look forward to hearing from you again, Travis, on a upcoming live episode.
Cool.
Awesome. Get my screen shared. All right. So yeah, definitely a good episode today. We learned the steps to take to grain match a room, how to work with user-defined properties there from Daniel in response to that forum question. And we also saw the new tools that will be available soon for unwrapping and fusing together the skins of millwork walls and reception areas and whatever else that you're creating with those tools and analyzing with Solid Model Analyzer. We also got a chance to hear from Travis just now. And so we, to the steps that it would take to create some signage using the bpoly and WMF in and out commands. And those are, honestly, to confess there, Travis, those are some commands I don't really use very often. So it was nice to see how you applied those commands there for the lettering. All right, well, let me queue up a few things that are coming up here on our future episodes next week. Starting with next week, we're going to be having the opportunity to hear from our Australian team as they develop the topic of creating subassembly drawers. So this is going to be an episode you won't want to miss if you've ever wondered how to do that. We're going to go live with this at a special time of 5:00 p.m. Pacific time here in the States, and that's on Wednesday, and it'll be 11:00 a.m. Australia Eastern time on their Thursday. So definitely one that you won't want to miss. Also, it is that time of year again where we are gearing up for our TechCon event. And so we host this annual event for our user groups and our developer conference here in Jacksonville, Oregon. The event campus is just 10 minutes away here from our headquarters office where we broadcast weekly for our live episodes. And so that event's going to be happening on May 3rd and 4th. And if you have not attended one of these events before, they are hosted annually. They're attended by business owners, engineers, users of the software, and even those who are curious about our solutions. So at these events, you're going to have opportunities to participate in group training events, smaller focused groups. We'll be breaking out into smaller groups, and attendees will have the chance to participate in best practices discussions led by our user advisory group. And we'll also be talking about some general shop practices as well. So if you want more information on this, you can visit our website, microvellum.com/TechCon-2018. and you can learn more about that and register for that upcoming event. All right. On behalf of our entire team here at Microvellum, I'd like to thank you for joining with us, and we will look forward to talking with you again on our next Microvellum Live episode.